This video will continue the problems on Laplace and Poisson's equation, just like what we've done in the previous video. Here also, the steps remains the same. They'll give you some conditions on potential, and they'll ask you to find V, E, and D values. Okay. So we are going to start with the Laplace or Poisson's equation. We're going to find the V, and then from that E, and then D. Okay. So let's start with the first question. So here, as you can see, some initial conditions are given in these two, and then they're given in volume charge density here. And ask you to calculate two things. One is the potential at x equal to 0.5 millimeter, and other one is intensity at x equal to 1 millimeter in free space. Okay. So first of all, you have to decide whether you are going to start with Laplace or Poisson's equation. If rho v is mentioned, you have to use Poisson's equation. If rho v is not given, then you can start with Laplace equation. That is, the right hand side will be 0 if it is Laplace. It will be minus rho v by epsilon if it is Poisson's equation. Okay. So since in this problem rho v is given, so you're going to start with Poisson's equation. Del square v equal to minus rho v by epsilon naught. And epsilon value is given by substituting all that, you are going to get this answer. You just pause the video and you can check the substitution that is done here. Okay. The next thing you're going to do is del square v. You have del square v equation for different coordinate systems. You have this Laplace equation for different coordinate systems. Here we are using Cartesian coordinate system since x is given. So for Cartesian coordinate system, the del square v equation is dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. But as you can see in the complete problem, only x-axis values are given. So y and z is not required here. Okay. So since y and z is not required, you don't have to take those two parts of the equation here. All you want is x component of the equation. So I have taken only the x part and I'm going to do the simplification using only that. Okay. So del square v actually has three parts in Cartesian. One is with respect to x, y and z. But since y, z is not given here, it is not required. Only the x component is taken. So now this is the equation I have. First step, as I told you, we are supposed to get the equation for potential. So I have to remove these differentiation terms. So since you have two differentiations, you will have to do two integration to remove it. So first time when I integrate it, I will be getting dou v by dou x equal to integration of 10 power 6 with respect to x is going to be 10 power 6 into x. And in these problems, whenever you are doing any integration, you have to add an integration constant C1. Again, there is one more differentiation. To remove it, again, you have to do the integration. And integration of x is going to be x squared by 2. Integration of constant is c1 into x. Plus, since you did one more integration, you are going to add another integration constant. And this is now your main equation. And in this, you have c1, c2, which you're supposed to find out. And to find c1 and c2, you are going to take the help of this initial conditions. That is what is done here. These are the two initial conditions. With the help of these two initial conditions, you can find out the value of c1 and c2. First condition is given as v equal to 0 at x equal to 0. So in this equation, make v 0 and x 0. Simplify it, you will get c2. Next, make v equal to 2, x equal to 1 millimeter. Simplify it, you will get c1 value. And once you get these two values, put it back in this main equation. That is what is done here. Okay. And the first part of the question, they have asked you to calculate v at x equal to 0.5 millimeter. So in this equation, replace x as 0.5 millimeter and then simplify it, you will get the potential value. Okay. And the second question was to find out E at x equal to 1 millimeter. So if you want E, the relation between E and V is given by this equation. E is equal to minus del V. Okay, this is gradient. Again, you have three different equations for gradient for coordinate systems. So you are using Cartesian coordinate, and in Cartesian coordinate only x-axis value you need. So you have to take only the x part of that. Simplify it. You have found out the equation. No, put that here. Do the differentiation. Simplify. You're going to get this equation. And since they're asking you to find for one particular value of x, that is 1 millimeter, you replace x by 1 millimeter. Find out the answer for Ex. Okay. So you can just pause the video or you can reduce the speed and check each step how it is done. It's a very simple problem. Okay. So we'll move on to the next question. In the next problem, they're asking you to determine the expression for electric field intensity in cylindrical coordinates between two planes insulated along z-axis, assuming a potential of, again the conditions are given here. First thing is, it is cylindrical coordinate system. And second, there is no rho v given, so it is Laplace equation, del square v equal to 0. And third thing, the axis in the initial condition is phi, which means in the cylindrical coordinate system, the Laplace equation, whatever terms you have, you need only the phi term in that. R and Z can be eliminated or ignored here. Okay, take only the phi term from the Laplace equation for cylindrical coordinate system, simplify it. You have to make sure that you're removing the differentiation terms and getting the equation for V. Okay, and every time you integrate, you have to add a integration constant. Okay, so you can pause the video and check the steps here, how it is done. Once you get this main equation for V, whatever initial conditions are given, use that initial condition to find out the C1, C2 values. Okay, so if I use this V equal to 0, phi equal to 0, I will get C2 as 0. And when I make V equal to 100 and phi equal to alpha in this, since C2 is 0, I'll get C1 as 100 by alpha. So these values are substituted back in the main equation and that gives me the potential answer. Okay, but the question is to find E. So E will be again minus del V. So what you have to do is write the phi component of cylindrical coordinate system gradient equation. Okay, only the phi component is taken. R and Z component in that equation is ignored. Only the phi part of that equation is taken and used here. Okay, so then again, whatever V equation you've got, put it here, simplify it, and that will give you the final answer for E. Okay, so you can just check the steps, solve it yourself and see if you're getting the same answer, if the answers are correct. Okay, then move on to the next question, third problem. They've given an equation for potential already. In the first part of the question, they're asking you to check whether del square V is 0. You have to prove that del square V is equal to 0. Or I can say, I just want to know whether it is satisfying Laplace equation or not. Okay, so del square V, I'll start from here. And here you see R phi Z. R phi Z component, which means it is cylindrical coordinate system. So in cylindrical coordinate system, whatever is the Laplace equation, you can use that. But again, you can see in your equation, there is no Z component. So dou square V by dou Z square is not required here. It will become 0. Only use the R and the phi component. So first what I have done here is I have to consider the first part of this R component and I have done the simplification. So pause the video and check the steps. You will get to know. Step by step you are simplifying it. I got this answer. Next I took the second component, phi component, and I did the same thing, simplified it, and I got the second answer. Now I added these two and I am checking whether it is cancelling and if I am getting 0 or not. Okay, so individually you find out the two parts of the equation, add them and see if the result is 0. If the result is 0, then it is proved. Otherwise, you can say it is not satisfying the Laplace equation. Okay, this is the first part of the question. So please pause or slow down the video and you can check all the steps in between, okay, how it is done. And now coming to the second part of the question. Here you see in the potential equation A and B values given. No? A and B are constants. You don't know what is the value. So in the second part, they're asking you to find the value of A and B. And conditions are given that the potential is 100 volt and intensity is 500 volt per meter at a particular point. Okay, so this is one condition. This is the second condition. Using these two, you can find out the constants A and B. So that is how it is done here. So I'm considering the first condition. V is given as 100 volt at this point. So in this expression, I will substitute these values. V as 100, R as 1 meter, and phi as 22.5. Substituting all that and simplifying, I am getting the equation as A plus B equal to 100. This is one equation, first equation. Next, what I have to do? Next, in the condition, E value is given as 500. So I have to first find equation for E, which is minus del V. So again, I told you this is cylindrical coordinate system, and since you need only R and phi component, Z is ignored. Only the R and phi components of gradient equation are written here. So substitute it, simplify it step by step. You can check it once how it is done. And after simplification and everything, I'm ending up with this result. Okay, but if you see the question, they've given you only 500 volts. Nothing is mentioned about direction. So I need to consider only the magnitude part. So I'll take this 4 into A minus B and equate it to the magnitude 500. which will give me an equation as a minus b 120 equal to 125. So I got these two equations. In first case, I got a plus b equal to 100. The second case, I got a minus b equal to 125. So these are simultaneous equations. By solving these two, I will be able to get the a and b values. Okay. The next problem. So here, this is your initial condition, okay? V equal to minus 2.5 at 0.02 meter and V is 15 at 0.35 meters. You are supposed to find E and V values, and the system is said to be spherical coordinate system, okay? So rho V is not given, so it is del square V equal to 0, Laplace equation, and spherical coordinate system. In spherical coordinate system, only the R component is taken. Okay, so this is the equation. Simplify it step by step. Remove the differentiation. To remove differentiation, you have to do integration, and every time you do integration, add a integration constant. And in the end, you're going to get a result like this. Okay, and in this C1, C2 needs to be calculated with the help of these initial values. That is what is done here. Okay, so sometimes what happens when you apply a initial condition, you may be able to get one of the constants answer directly, but in this case you're not able to get any one individual answer. You're going to get an equation format. So you just have to solve these two equations to get the C1 C2 values. Once you get the C1 C2 values, put them back in this main equation. Okay, so just see the steps how it is done individually, and then this is your final expression. And in the question, they're asking you to find E value and D value. So E is calculated as minus del V. Spherical coordinate system gradient equation in R direction. Okay, so by simplifying, you will get the E value. And D is nothing but epsilon into E. Just multiply this with epsilon, you will get the answer. And if you just check the question, nowhere in the question they have given you it is free space or anything. So don't write epsilon not here. Just write epsilon because you don't know whether it is free space or if it is a dielectric. So just keep it as it is. Just keep epsilon here. Okay. The next problem. They've given a vector E. Equation is given for intensity and they're asking you to check whether it represents a possible electric field. Okay. So how do you check whether it exists or not is, if I do this operation del square V and if I get the answer as 0, then it means that there is no electric field. This particular E does not exist. But if I don't get the answer as 0, then it says that that electric field exists in that region. And they are asking you to prove this all, to show, check whether it exists. So what should you do? You perform this del square V operation and see whether you are getting the answer as not equal to 0. If it is not equal to 0, then you can say that this particular electric field exists in this region. Okay, but to do del square V, you need V equation. But what is given is E, right? So use the relation E is equal to minus del V. Del V will be minus E, right? Minus can be taken to the other side. And on both the sides, I'm taking dot product with del. So del dot del is nothing but del square. And del dot E will be the dot product, or you can say divergence of vector E. This is the equation for divergence in Cartesian system. So I'm finding del square V, which is nothing but here minus of del dot E. So here it is Ex. Ex means it is the coefficient of X component. Vy is coefficient of Ay component. Ez will be coefficient of Az component. So I have substituted all that, done the partial differentiation. And in the end, we can see that none of the terms gets cancelled. So I can say that the answer is not going to be equal to 0. So if it's not going to be equal to 0, then this particular field exists. Okay, that's all you have to do in this. So you can just reduce the speed or pause the video and check this steps. Now the last problem under this concept, again they're asking you to find E value at a particular point for two coaxial conducting cylinders with initial conditions. So whenever it is talking about coaxial cylinder or coaxial conductors, it is cylindrical coordinate system. And in cylindrical coordinate system, you need to write the equation for Laplace. And here the axis which is given as rho. Rho means radius. Either it can be given as rho or it can be written as r. That is fine. Okay. So since only radius is given, take only the radius part. That is r part or rho part. And do the simplification step by step. Okay. So you can just check here how it is done. I need to remove differentiation term. So I have to integrate it. And every time I integrate, I'm going to add an integration constant. Then I've taken this rho to the other side, becomes C1 by rho. Again, I have to do the integration. Integration of 1 by rho will be natural log of rho plus another integration constant. To find C1 and C2, conditions are given here. Initial conditions are mentioned here. Use each one of them. You will get two equations. Solving the two equations, you will be able to find C1, C2 values. And these C1, C2 values, put it back in this main equation. That will give you V. And if you want E, you should do minus del V. By doing minus del V, again, see, you are doing Laplace or you are doing gradient. You are supposed to take the same coordinate system. If it is cylindrical, both will be cylindrical. If it's spherical, both will be spherical. And again, which axis you want, only that axis part of the equation should be considered. Because the equation will have all the three axes. If it is cylindrical, it will have R, phi and Z. But phi and Z is not mentioned here. So only R component should be taken in the equation. Okay. So both the equations, same thing applies. Okay. So this is minus del V. And by substituting V and differentiating it, I got this answer. But read the question carefully. They are not asking you the equation. They are asking you to find the value of E at this point. But the point that is given is in Cartesian system. The point is given in Cartesian system. You need to find out the cylindrical system value. Because in this equation, you have to substitute the value of rho, right? So rho is root of r square, x square plus y square. Sorry, root of x square plus y square. From that, I got the answer as root 10. Substitute it here and get the value. Okay. So these are the problems you have under Laplace and Poisson's equation, but this is not all. We have a few more problems to be done. But in those problems, no, apart from finding out E and D, you will be calculating two more new parameters. One of them is called charge Q, other one is called as capacitance C. Okay, so I'll be in the next video, I'll be explaining about those problems, how to solve it. It's very simple. It's quite simple. The starting part is everything just like this. Until you find out E, it is going to be the same. From E, you have to calculate D, and from D, you will be calculating surface charge density rho s, and from rho s, charge, from charge, capacitance. Okay, so we'll solve some example problems on those capacitance values. We'll see. We'll do that in the next video. Thank you.